Today I'm going to teach you a little bit about linear programming. And if you know how to do graphing inequalities, you're going to be fine today with linear programming. Okay? First, let me confuse you a little bit. Okay? And then I will do some translation from math to English, and then you'll be fine. Okay? First of all, what do you have when we have linear programming? You have a feasible region formed by graphing a system of inequalities. Okay? So when we're doing linear program, we have a feasible region formed by graphing a system of inequalities. Wait a second. How's that any different than what we did yesterday? What did we have yesterday? A system of inequalities, right? What did we do with that system of inequalities? We graphed it and then we shaded, right? We shaded where all of the inequalities were true. We found the shaded area that was true. So another word for shaded area? Feasible region. So basically, we have a shaded area when we graph a system of inequalities. You already know how to do that, don't you? We did it yesterday. Okay? So here is where it changes just slightly. And it's not even that it changes, it's just that it adds another step or two. Okay? Under these restrictions, under the system of inequality restrictions, we must maximize or minimize some other function. Most of the functions we're going to deal with are cost and time, and most of the ones that we're going to deal with are cost. Okay? How do you do it? Well, here's the deal. Let's start on number 1, and when we get to this step, I think you'll know what to do. How about that? We'll go back and fill that in. Okay? So, how does this look any different than you had yesterday? Again, I'm trying to make a point. How does this look any different than what we had yesterday? It doesn't. So we're going to do the same thing that we did yesterday. We're going to graph this first line by going up 4, then down 2, right 1. And because we're good math students, we're going to put all the points on the graph that we possibly can. Not just 2 or 3, but all of them. I know it's a solid line because it's less than or equal, and I know it's below because it's less than or equal. Okay? Okay so far?
Yes.
How do I graph the second line?
Plus 7.
So go up 7, good. Down 1. Down 1, left 1. Because down 1 is -1, left 1 is -1. Wouldn't that give me a slope of 1? Because there was really one place that I could only go up 1, right 1, correct? I know it's a solid line because it is less than or equal to. I know it's below this line because it is less than or equal to. So the last equation is the one we freak out on? Okay, good. Last one is where we subtract x from both sides and get 3y is greater than or equal to -x minus 3, and then divide everything by 3. So y is greater than or equal to -1/3 x minus 1. Right? So I go down 1, and then down 1, right 3. Or up 1, left 3. Again, it's a solid line. That this time I shade above because it is greater than. So does anyone see our shaded area? Where will I shade? Inside the triangle. Very good. That's where all of our arrows are pointing. So I have a higher level thinking question for you. I went through every step of saying it's a solid line and we shade however, because that's what we did yesterday, right?
Yes.
Okay, let me ask you the higher level thinking question in just a second. Is that fair enough? Okay. So what I have to do is I have to find the maximum and the minimum values for C using this equation. Am I supposed to graph this equation? No, it's completely separate from my list of things I had to graph, right? Okay. So how many places do I have to choose from in this shaded area? A lot, right? An infinite amount, in fact, right? But even if we talk about just the intersections, like these.
Miss Kingston, do you have Hannah Taylor?
Yes, I do.
Can you please send her to the office?
Does she need to come right now?
Yes, ma'am.
Okay, thank you.
Thank you.
Hannah, you need to go to the office. Even if we just talk about these intersections, how many of those do we have in here? A lot still, right? A lot. So what I would like you to know is that we're going to be able to use stuff other mathematicians have taught us. It's nice when we don't have to create everything every time, right? We don't have to figure out the formula or whatever. We can just use stuff that other mathematicians have figured out. Other mathematicians have figured out that if this is the shaded area, there's some pretty specific places that are going to help us find our maximum and minimum. And it'll be those places every single time. Okay? And those places are going to be here, here, and here. What are those called? A vertex. It's the vertices of the shape. Okay? So we're going to come back up here and say we're going to use the vertices of the region. These mathematicians have found that if I'm trying to find the maximum, whichever one of these points ends up being the maximum, there's not going to be any other point in this shaded area that it's going to give us any higher number than one of the vertices. They also figured out that when I find the vertex that's the minimum, there's also not any point in this region that's going to give me any value less than the vertex that is the minimum. So instead of having to try 50 or 60 different points inside the shape, I can try 3. Okay? So what are my vertices of this shape? What's one vertex? -1, 6. What's another vertex? Say again? 3, -2. Thank you. And our last one? -6, 1. Good. So what I have to do is I have to put it into this equation right here. It's separate. It tells me this is separate. I told you a moment ago this is going to have a lot to do with either cost or time. There's other things it can have to do with. Most of the stuff we're dealing with is cost or time. Okay? So let's pretend this C actually stands for cost. So this problem might be something like it's $8 for the X value and $11 for the Y value. Which one is going to give us the most money? Or it's $8 for the X value and $11 for the Y value. Which one is going to give us the least amount of money? Okay? So let's put these values into our cost equation. So 8 times -1 plus 11 times 6. 8 times -1 is what? -8. 11 times 6 is 66, and -8 is 58. 8 times 3 plus 11 times -2. What's 8 times 3? 24. What's 11 times -2? 24, and -22 is 2. 8 times -6 plus 11 times 1. What's 8 times -6? -48. What's 11 times 1? -48, and 11 is -37. So here, wait, are you ready for the hard part? Which of these three numbers is the biggest? Then it's the maximum. Which of these three numbers is the smallest?
-37.
Then it's the minimum. Done. Okay? So really, compared to yesterday, all we have to do is find the vertices and fill in this table. Right? That's the only difference. Okay? So what I need you to do for homework, first of all, is 2, 3, and 4. 2, 3, and 4. Okay? The other pages I gave you looked like this, and I gave you 4 of them, correct? Let me take that back. Somebody gave you 4 of them. Okay? Thank you for the volunteers who passed those out. I appreciate that. Okay? I am going to do number 1 with you. You are going to do number 3 for homework. Why did I give you 2 and 4? I had already copied them, not realizing I had misplanned. Okay? So I went ahead and gave them to you so you could do them for extra credit if you wish. Okay? But, so, just to be clear, I need everybody to be clear. On this page, you are doing 2, 3, and 4. And on these pages, you are doing number 3. Got it? Then let's work on number 1. Military rations. A military unit is about to embark on an extended mission. The unit carries food in 2 types of servings. Power bars, which resemble little snack cakes, and mini meals, which resemble small microwave dinners. These servings have different nutritional value as shown in the chart. The unit commanders are trying to plan how many of each type of meal to carry on the mission, according to the restrictions below. First restriction. Each day, a soldier can have no more than 12 total servings. Restriction number 2. Each day, a soldier must consume at least 300 grams of carbs. Restriction number 3. Each day, a soldier must consume at least 2,015 calories. For this situation, define your variables, then write a system of inequalities to describe the constraints. Next, graph the feasible region for the numbers of each type of serving a soldier can consume in a day. Okay? So first of all, there's a lot of words. Okay? There's probably only one word in that whole thing that you may not understand. And I'm thinking it might be this word right here. Constraints. What is a constraint? It's like a requirement. It's like rules. In this particular kind of problem, it's our inequalities. Okay? Those are our constraints. It's the edges our inequalities provide for us. Okay? So let's start out by doing what it asks. Let's first define our variables. Since we're graphing, what do you think we should choose for our variables?
X and Y.
X and Y are a great idea. Except now I need to define them, not just choose them. I have to say what they each represent. What does X represent?
Carbs.
Okay? So some of you are saying carbs and calories. This crazy kid from earlier was like, it should be power bars and mini meals. So I want to know what you think it should be.
Power bars and mini meals.
How do you know it should be power bars and mini meals?
Crazy kid.
Graph the feasible region for the number of each type of serving a soldier can consume. Doesn't it tell you? So X should be the number of power bars, and Y should be the number of mini meals. So according to my directions, I have to define the variables. I just did that, right? Then write a system of inequalities to describe the constraints. What is my system of inequalities going to look like?
X plus Y is
Okay, so X plus Y is what?
greater than or equal to, less than or equal
Less than or equal to 12? Where did you get that from?
to. I use, because it says they can't have more than 12 total servings.
Okay,
So I just
so if
add-
I take the number of power bars and the number of mini meals, that should have something to do with 12. You're not very confident about what sign that is, and I need you to be. What sign do you think it ought to be there?
Less than or
That's what you said first, right? You said less than or equal, and then you questioned yourself and said greater than or equal. Now Anthony's saying less than or equal. So were you right the first time along with Anthony, or were you right when you changed your mind?
right the first time.
Right the first time. Okay? It says he can have no more than 12. Think about it. Give yourself an example. Can he have 13? No, because he can have no more than 12. 13 is more than 12, so it has to be the other direction. It has to be less than 12. Okay? So less than or equal to 12. Now I am going to have to graph that, aren't I? So I need to probably go ahead and get that into slope-intercept form. Oh my gosh, I just did that and didn't show any work. Are you okay with that? How did I get from here to here? I subtracted x from both sides. Okay, subtracted x from both sides. Are we done? Is that all the constraints we have? What else do we have?
One more. Don't
2 more.
Something about what?
Carbohydrates.
Something about carbohydrates. Tell me what you know about carbohydrates.
There's 75 in power bars.
They need 300 a day.
There's 75 in a power bar. There's 15 in a mini meal, and they need how much? 300 in a day? Exactly 300? At least 300 means what? Greater than or equal to. Very good. Okay? So I just heard the sound, and it was a screeching sound of people going, wait a second, where'd that come from? Where did it come from? If I subtract 75x from both sides, I get 15y is greater than or equal to negative 75x plus 300. And then if I divide everything by 15, what do I get? That. Does that make sense? Okay, is that all the constraints? Are we done? One more? How do you know there's one more? So there's always going to be 3? It could be different. How are you going to know when you're done? How are you going to know when you have them all? Does it say there's 3 constraints here? So there's 2 hints I can give you. Okay. Number 1, the first hint is if Mrs. Kingston says you're going to have 4 constraints on this problem, that would be a good clue that there's going to be 4. Okay? Or, what happens when you run out of information? Shouldn't you have them all? So make sure you use all the information that's there. Okay? So, you're telling me there's one more? What do you think it should be? 155x plus 310y. And what is that inequality all about? Calories. Very good. Okay? So subtracting 155x from both sides gives me 310y is greater than or equal to negative 155x. Plus 2015, I divide everything by 310. Y is greater than or equal to negative 1/2 x plus 6.5. One, two, 3. Those are my 3 constraints. I've got a graph, correct? Okay, I'm not gonna really go really slow on these graphing lines, inequalities, because of the fact that that's what we've been doing. pretty consistently for the last couple days. Okay? So here I am graphing the first line. It crosses at 12, has a slope of negative 1 over 1, so I went down 1, right 1. Okay? It's a solid line. And I'm shading where? Less than or equal? Below. Down. Okay? Uh-oh. I said, uh-oh. Because my y-intercept is what? 20. Great. That means I'm going to have to use my brain. Let's pretend I go up 20. I come down 5 over 1. Where am I? 15, right? And over 1? What if I come down 5 more and over 1? Where am I? Right here, aren't I? Then I come down 5 more and over 1. Down 5 more and over 1. So even though that intercept is not on my graph, I can still use what I know, can't I? This is greater than or equal, so I'm shading above. .5. It's greater than, so I'm shading above. So where am I shading? This triangle?
Wait, so if it's down 1 to the right 2, and you're at 6.5, why did you only go down a half?
And over 1?
Yeah.
Jake, is this the same as that?
Yes, sir.
So what I did was I went down 1/2 and over 1, because then I was at a nice solid point, and I could go down 1 over 2, down 1 over 2.
Okay.
Does that make sense? Are you lying?
No.
Okay. So where am I shading? Triangle. So remember, up until yesterday, we were done, right? Or excuse me, through yesterday we were finished. That was the end of the problem. Because this is a programming problem, we have a couple more steps to do. What do I have to find? I have to find my vertices, right?
Right.
Where are my vertices?
11,
11, 1. If it's a triangle, how many vertices I ought to have?
1.
So what's the second one?
3, 5.
3, 5.
2, 11.
I got 11, 1, so I need
2, 10.
2, 10. Okay? So those are my vertices. What am I supposed to have now to help me figure out what the answer is? Some sort of other equation, right? But you told me a minute ago I used all the stuff up here. Oh, there's stuff below. Do you see the equation right here? A contracted? That's not like a disease. The contracted food service charges the military $1.25 for each power bar and $3.75 for each mini meal. Determine the maximum and minimum costs for feeding 250 troops on a 30-day mission. So what's my C equals? What's my cost equal? 125x plus 375y. So I'm going to say 125 times 11 plus 375 times 1. Everybody see where that came from? This is my x value, this is my y value. I put the x in for x and the y in for y. I do math, 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 and what do I get? Which one's this one? 1750? This is money, isn't it? It's a cost equation. Okay, so what about 3.5? I have $1.25 times 3 plus $3.75 times 5. What? I don't think so. I think this one's $22.50. $1.25, that's a 2. $1.25 times 2 plus $3.75 times 10 equals 40. So what we're trying to figure out is the maximum and minimum costs. Which one is the maximum cost? The last one. Which one's the minimum cost? The first one. Now, have I really answered the question though? I found the maximum cost per day. What am I trying to find? 250 troops for 30 days. So if I have 1750, if we're talking about the minimum, and I have 1750 for 250 troops for 30 days, what am I going to end up with? 1750 times 250 times 30. 131,250 dollars. What about my maximum? It was $40. 40 times 250 times 30. $300,000. Okay? Now, guys, a lot of times I have to tell you, a lot of times before this part, when we get to this part of the problem, we're done. So be careful when you read the directions what you're trying to find. And this one's very clear. We're not trying to find the charge per day. We're trying to find something more. But sometimes the charge might be per day, so when you get here, you're finished, okay? So let me caution you, please, to read the directions. Okay? Everybody clear about what your homework assignment is? 2, 3, and 4 on this page, and number 3 of the programming problems. Okay? Any questions? Peace.